This is James Grass, and this is my Lab 2 presentation. In this lab, I worked with tape to learn and demonstrate a few concepts. I covered the concept of charge, made estimates, simplified assumptions, and learned about the excess charge on everyday objects. I saw if a charged tape could make a horizontal piece of tape rise, and I calculated the tape's charge. I calculated the charge of the tape, accounting for the charge not as a single point, but distributed along the length of the tape. The length of my pieces of tape were each 10 centimeters, and they each had a mass of 0.1 grams. The 0.1 grams was calculated from the measurements of the tape's length and width, so it is not entirely as exact as if I weighed them on a scale, but it is an approximation of the mass, which could have affected the results below. The distance at which my tapes began to float was 1.2 centimeters, and the magnitude of the gravitational force on the floating piece of tape was 9.8 times 10 to the negative fourth newtons. Due to these discrepancies, likely to imprecise measurement, I found the magnitude of the electric force of the floating tape to be 1.2 newtons, which seems inappropriately high. However, this is likely due to my measurements and not my calculations, as I've gone over my calculations multiple times. The magnitude of my charge of one piece of tape was 3.9598 times 10 to the negative 9 coulombs, and that was calculated with my computational model. To get this value, I had to assume that air resistance was negligible on a moving object, and I had to assume that each U-tape I made had the same amount of charge evenly distributed along the length of tape, while in reality those charges were likely different and air resistance probably had an effect. This is the output window from my code with many of the values that I've already gone over, as well as a digital model of what is going on. And here is the first section of my code. I started my code off listing physical constants. The next portion is my function for calculation of an electric field. I didn't actually find this necessary to use because the way to find the value of the electric field was more so related to the force of gravity. However, I kept it in due to the fact that I did not know if it could be potentially useful or not, and it did not harm my code to add it. Below that, I have the function that we were given that creates a line of charge, along with all of the values that I filled in based on my data calculations. As you can see, I also left the comments in that we were given. Next, I have my values and calculations. There's the values for my lab, the mass, and the distance between the tapes. I've got my calculation for the force of gravity, my force of the electric field, and my calculation of the charge of the tape. Below, in case I needed it, I had the tape's width and the tape's length. Below that, I had print statements to print all of the values that I had already known at that point in the code that had already been calculated. Below that, I began with the code to create the objects that are in the viewing window. The comments are just to help me understand which tape was the bottom tape and which tape was the top tape. Tape A was the bottom tape and tape B was the top tape. Those correspond due to the nomenclature in the lab manual, so I tried to stick to the lab manual when I was performing the lab. However, the code used a different naming, so I have that to help keep everything clear what's what. Then I have the creation of my line charges, and on the next page I have the calculations of the electric field and the electric force using the code from the template code. I filled in the values that I'd calculated and the vector locations that I had found and used. And at the end, I have my print statements to output all of my calculations as we were required to do in the template and in the instructions. And that's the end of my lab report.